So we move ahead now to Chapter 9, which is going to be the confidence interval chapter. Dun, dun, dun. So let's look at the Chapter 9 notes. The first thing we run into that needs a calculator to be used is finding the critical values. I'm not going to do both of these. I'm just going to do one of them. For the fun of it, I guess I'm going to do the 99%. Okay, so if the middle portion of your normal curve is 99%, that means that the two tails together make up 1%, right? So that means each tail on its own is a half of a percent, which is 0.005. So for example, if you take 0.01 divided by 2, you get 0.005, right? Okay, so now to find the z-score, I'm going to go second distribution, number 3, which is inverse norm, 0.005, close parentheses, enter. Or by the same token, you could have done inverse norm 0.995, right? 995. That would also have been. This is the negative one, this is the positive one. They probably want the positive one for this particular problem, so give them the positive one. So 2.576. Checking normality is no big deal. Let's move on to finding an actual confidence interval. So I've got this data set right here. And the first thing they want us to do is find the point estimate and then make a confidence interval. Okay, so because of course you've trained yourself as a good statistics student, when you see a column of data like that or a row of data, you need to go to Stat, Edit, and you need to type those numbers in. We better go up and press Clear, Enter. Clear out that old junk. You don't want that anymore. Okay, 699, 560, 414. 70, 521, 63, 727, 413. Alright, clear those key histories. You don't need to see all that. Okay, so there's the data right there. Now, the point estimate is going to be the sample mean, which you know how to find that. You learned it in Chapter 3, but I'm going to show you another little trick. Let's find the confidence interval. In this particular problem, they gave us the population standard deviation. See that right there? They're giving us the population standard deviation. In other words, they're giving us sigma. It's given. That means that we're doing stats, move to the right to tests, pick number 7, z interval. You're making an interval, but you know sigma. Since you know sigma, you get to do this. Now, data is what you use if you have a row of data, which we did. Sigma. Sigma was given to you. It's 113. Enter. List. My data is an L1, so I'm going to leave that as L1. Frequency. I don't have any frequency, so it's just left as 1. What kind of confidence interval do I want? I want 95%. So let me go down, 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 calculate, and press Enter. There you go. You can see the point estimate. The point estimate is X bar, which is 570.875, right? That's the point estimate. Enter. Oopsie. Close. And then the confidence interval itself is actually this guy right here, 492.57 to 649.18. Now, if you're in the face-to-face class, you're going to actually have to show the formula and all that good stuff to get there. But this is that would be the final answer, which would be worth a point. Awesome. Now, what if it was a different kind of problem and they didn't give you all that data? Well, then you would have used stats, right? So you would have gone to stat, to the right to tests, pick number 7, but you would have gone over here to stats, press enter, and then you would be typing it in. Alright, I think that's the end of this section. I'll see you here for the next question. Oops, before I go away, let me just show you this one at the very, very last. It's got a sigma of 0.7. It's got a mean of 98.25. It's got an N, which was 92, and a confidence level, which is 0.99. This is body temperature example, the very last thing in those notes. And see, 98.06 to 98.4. That's how to make the stats work for you. They gave you everything. You weren't given a column of data like you were in the other problem. All right, that really is the end of 9.1. Now I'll see you here for 9.2.